Hello everyone, welcome to my session in BIM Coordinators Summit 2023. Today I'm going to present to you brain controlled smart homes. So my name is Ahmed Zakzouk. I'm a PhD researcher at Dresden University of Technology. So let's get started. So to give you a brief overview about myself, my name is Ahmed Zakzouk. I'm working as a solution architect at Autodesk. I'm also a PhD researcher at the Institute of Construction Informatics at Dresden University of Technology. I'm based in Frankfurt in Germany. So I have over 7 years of experience in the EAC tech industry, working in big construction companies and as well as EAC software providers. And I'm with Autodesk since beginning of last year. This work that I'm going to present to you is part of my PhD research at, as I said, at Dresden University of Technology. Let's start. So our agenda today, I will start with the introduction about the research area and give you a literature review about the direct building control and autonomous building control, and then I will describe my focus and then we go with the solution, so the architecture and the different milestones starting from digital twin to the reinforcement learning to smart building control. So let's start. So to control a building, we have three types of control. We have a direct control, we have autonomous control, and we have a semi-autonomous control, which is actually a hybrid of both direct and autonomous. So for direct control, we would need a human building interface. So we need to involve an interface between the human and the building. And this can have different interfaces. For example, we have the manual interface where the user can open the building component with his hands. And we have sensor interface, voice interface, voice interface like Alexa and so on. So all of this requires one thing, involving a building human action. So, which means that the building cannot take control of its own, it requires an input from the user. However, we have different technologies, yeah. Now, we have new technologies like brain-computer interface, where we can even involve a user feedback only from brain signals, which really requires the least effort from the human, as well as it can work for everyone. And this is what I'm going to consider in my research as a user feedback system. Okay, so as I said, we have direct control, manual interface. We have also many examples about the gesture interface, like using image recognition and to control a building, or let's say by just a movement or something like that. So that's involve technology like image processing and so on. We have also the voice interface, which we all know, like Alexa, Google Home, and so on, which uses natural language processing, which is a subfield of the AI. And last but not least, what I'm going to focus on is utilizing the brain-computer interface, which means that using supervised machine learning algorithms, you can take these brain signals. There are many technologies. I'm using the electrocamography, which I will explain later on, via a non-invasive device. So you can capture these brain signals and train your model to understand, for example, mental commands, to send specific commands from your brain to control an object. So this is going to be my focus. Also, on the other side, we have the autonomous building control, which really requires the building, that the management system, to take control of the building without involving a human. So, which means that system has to be pre-programmed. It maybe has optimization algorithms. It may run real-time simulations, and so on and so on. But can also utilize a reinforcement learning control algorithm in the building control process. So this why we use reinforcement learning? So with reinforcement learning, we can train the building to understand us better. And the good thing here, that we can involve the user feedback in the training process to evaluate the rewards and so on, so that until the building understand the user and really expects its behavior. So And again, this will be my focus in my research. So why reinforcement learning? So a lot of researchers found out that utilizing reinforcement learning in building control can save a lot of energy, reaches up to more than 25%, as you see. So that's good amount of energy saving that can make us convinced to use this technology in building control. So basically, to give you an overview about utilizing reinforcement learning in building control, so the idea is you have to simulate your environment, you have to understand your rewards, is it the comfort, is it the energy, is it the cost, and so on. And you need to understand the states, what they really want to change. Is it maybe I have a window I want to open or close, I have a door, maybe, I don't know. So we need to identify the states, different states. And then after the training, the reinforcement learning, depending on the learning algorithm, it will try to get an optimal policy to get the maximum reward possible. So what is my focus in my research? That's a good point. So what I'm doing, I'm utilizing semi-autonomous approach in the training phase. So which means that I use reinforcement learning as well as together with brain-computer interface to get the user feedback in the training phase. Afterwards, let's say 1 month, 2 weeks, let's say, and then you can have an autonomous approach. So the building control now, after the training, rewarding, evaluation, and so on, it will start to understand your needs. It will start to understand, for example, your thermal comfort, your, I don't know, humidity, comfort level, your occupancy pattern, and so on. So in the operation phase, it will start to work on autonomous way. This is how my solution looks like. So basically, I'm using the emotive headset to send through OSC, which is Open Sound Control, network broadcasting. So through this network broadcasting, I'm sending the signals to our web application, a Node.js web server. In this case, I have a mini PC. We can involve in this maybe a Raspberry Pi, but I decided to involve a mini PC in this process. And then I have the smart home kit, which I built here using microbit controller to communicate via Bluetooth. So by the end, I can communicate the signal between my brain to the smart building component. So just to give you an idea, I started in milestone level 0 to build the model in order to prepare for the digital twin. So this is milestone 0. And I started to build the web application using Node.js. So as you see, this is my web application. I'm using here Autodesk Platform Services, ABS Viewer, as well as the Data Visualization API. So basically, I'm representing here the servos with red circles and the sensors with green ones. I can have even here a full screen mode and so on. So the idea that I would need to pair via Bluetooth first to connect to the building and so on. So that's what I'm going to describe in the next slide. I started to work on the microbit controller to program it to be able to control the servos or the servo or the via Bluetooth signal. So which means that I do send a Bluetooth command, and it gets via Bluetooth, and then it starts to control the window and the door as well as the fan module that we have here in the building. So by the end, bidirectional communication via Bluetooth works, and I'm going to show you building physical model, smart building physical model. As I said, I have two servers, one in the window, one is to control the door here. I have several sensor, temperature, and also I have here a LED. This is a LED lamp, and I have here a motion sensor, temperature sensor, as well as I have here the steam sensor for water, the water drops, so that we can identify rain, for example. I have here a fan, and I have here the bar unit as well as the gas sensor. And here I have RGB LED as well. So this is the smart building, and you see beside it you see the digital twin application, as you can see here, um, and so on. So what we are going to do, so let me turn on the smart home building, and then I'm going to pair via Bluetooth. As you see here, I can connect with the microbit controller. I'm now connected. You will see now a smiley face, which means that I am connected. So first thing to do, I just want to show you, if I click on this servo, I'm going to close the window. So here's our window. Let's close the window. So I close the window. If I want to open it again, I just click once more, and now the window is opened. Okay, that's good. Let's see what we can do also for the spiral door. As you see, I open the door. Let's close the door. Yeah. As you see, I can control the building from the smart, from the digital twin. Workflow, what I showed you is actually working in bidirectional way. So I can read values from the microbit controller into the web app, and I can also send commands via web Bluetooth. So I'm using here web Bluetooth.
So now I'm going
Functionality.
to show you milestone 2, where I am going to communicate the brain signals from the brain headset to the web server, and it will communicate it to the smart building and to control then the windows and doors only with the brain signals. So let's start the transmission of the brain signals.
So as you see, my brain signals send. Now I'm in the neutral state, but if I imagine a push command, so as you see, I closed the window with my thoughts. Now I'm going to open the window with my thoughts. As you see, I have been able to open the window. So let's try again. Let's imagine. So as I saw to you, now I can program it to control also the doors. Also I can control the fan and so on, the lighting and so on. So this is my setup. I have here the monitor, and I have here my web server, which is a mini PC here. This is my mini PC, and here I have the smart building inside, and I'm wearing the brain headset. So this is my system.
So what I'm going to do now, which is still this work is still in progress, is to have the reinforcement learning controlling the building. So it will take the rewards from the brain signals as a comfort assessment from the user, along with the energy saving, to be able to autonomously control the building later on.
So is to read the temperature and humidity, occupancy, and steam sensors readings, and use it as an input for the assessment of the comfort and for the energy. And by the end was this decision of closing or opening the window. So what I OpenAI with OpenAI Gym and TensorFlow, I started to build to model the reinforcement learning problem. As if the problem is restricted to one space used by one person. This is my limited scope. Now I'm not getting the brain signals into the OpenAI environment, but I'm using this the general ideal comfort assessment, which means that the temperature ideally needs to be from 19 to 23, but later on I would need to involve now the brain signals as an input for comfortable assessment. I'm still working on that, so looking forward for the next steps. And thank you very much for listening, and see you soon.